Hello again. I'm here this time to talk about the World Ocean Database and how it can facilitate the understanding of ocean climate for the UN Decade of the Ocean. These are my co-authors, including Hernan Garcia, who's here, who's part of the World Ocean Database, but also a partner as the director of the World Data Center for Oceanography, World Data Service, excuse me. And this project, the World Ocean Database, was started by Sid Levitas in the 1990s. So here's this picture again from the United Nations Decade of the Ocean. And again, just to emphasize the idea of gathering ocean stakeholders worldwide behind a common framework that will ensure ocean science can fully support countries in creating improved conditions for sustainable development of the ocean. And we'll look at a little different aspect of that now, kind of the big picture of how the data can come together and be used for some aspects of understanding the ocean and to the benefit of society. And this is a big picture, very big picture, investigating the scientific problem and societal solutions. We're going to look at the Earth's energy imbalance. So this is from the IPCC, the Intergovernmental Panel on Climate Change report in 2013. And it's a diagram of the Earth's energy system. And the units are watts per meter squared, and the incoming solar radiation is in yellow on the left there, and on the right is the outgoing, or not outgoing, long wave radiation. And the part of great interest, these are some really big numbers, 340 watts per meter squared, big number, and going out 239 and so on, is in that red circle there, the 0.6. Relatively very small amount, 0.6 watts per meter squared, which is the imbalance. That which is the outgoing does not balance the incoming. So that's the part of great interest, because that is that which stays in and affects the Earth system. And this is again a figure from the IPCC, and it shows on the y-axis are zeta joules, 10 to the 21st joules, and on the x-axis is years from 1970. And the blue part there is the contribution to the excess heat in the Earth system from the ocean. The light blue from the upper ocean, dark blue from the deep ocean. Then you also see contributions from ice, land, and atmosphere, which are those very small parts at the bottom there. So what we experience is basically the atmosphere. But if you want to understand the climate system and how much the Earth is sequestering heat, you have to understand how much heat is going into the ocean. And so how do we do that? And I should say we don't, to understand into the UN Decade of the Ocean, into the future, we have to understand how the Earth has been changing at the present and into the past. So what we need is a data set for the subsurface ocean profile data. And this is a diagram. This is years from 1900 to the present, and to 2018, actually not quite the present, and the number of oceanographic casts, sets of profiles that have been taken with all the different instrumentations. Black is the bottle data, and I'll speak about the other instruments on the next slide, but this just shows that before about 1950, there were very few data, mostly bottle data, and since then the observing system has grown, and hence the number of observations. And gathering them together is important to be able to look at ocean heat content or other subsurface oceanographic changes. And these data are from the World Ocean Database. So the World Ocean Database is a heterogeneous aggregation of ocean profile data, because there's been a lot of instrumentations over time, and they take ocean profiles for a lot of different reasons, not particularly in the global sense. Often ocean expeditions are regional or basin-wide at the best. And so we need to gather the data from all these different cruises and projects, gather them together to get a full global picture. So we have the different types. You see the bottles, which have Nansen and then Niskin bottles since the late 1800s, early 1900s. The mechanical bathythermograph, which was the first to measure continuous profile that began just before World War II. Then you have the expendable bathythermographs, which made it much easier to drop from a merchant ship. and those came in about 1967. The conductivity, temperature, depth, with the bottle rosette there you see, and those are basically the research grade temperature and salinity. Then you have some iterations on that, undulating ocean recorders, basically a CTD that undulates behind the ship. You have profiling floats, which is mainly now the Argo program, which are now autonomous floats. You don't need to send the ship out to continuously take information. You just drop a profiling float, and every 10 days it'll send its profile information to a satellite. You have moored buoys like the Tau array in the Pacific Ocean, Rama and Parada in the Indian and Atlantic across the tropics. You have drifting buoys, drifting ice buoys up in the Arctic right now, the Ice Tethered Profiling Program, which is built on, there was also the Japanese program, the JCAD, I can't remember what that stands for, I'm sorry. Then you also have other sources like instrumented pinnipeds, which basically is looking to find out biological information about habits of the pinnipeds, but they're taking temperature and salinity information to sometimes to depths deeper than 1,000 meters. You have gliders which are coming in, especially in more coastal regions. Then there are also surface data and plankton, which are not major parts of the World Ocean Database. Those are covered by other databases, but there are some of those data in there as well. So the variables in the World Ocean Database, I've talked basically about temperature so far, but there's a lot of other variables: salinity, oxygen, phosphate. So the nutrients, chlorophyll, there's the carbon cycle variables. There are tracers such as chlorofluorocarbons and tritium, helium. Basically anything that's measured from a bottle or some other type of instrumentation is in there. And this includes now the BioArgo variables and the different instruments. I mentioned most of those. Well, I mentioned all of those already. So the blue, we don't have the expertise for all of these data, but we do for temperature, salinity, oxygen, and the nutrients. So those are that we give quality control beyond just the basic automatic checks. So when talking about delayed mode data, so a lot of data doesn't even go out over the GTS, although many of the data do go out. And the World Ocean Database now is updated every 3 months. It's updated, and we continuously are gathering data at different time scales. So quarterly, we get data from ICES, I'm losing all my acronyms. International Council for the Exploration of the Seas, based in Copenhagen. CCHDO, the Ice Tethered Buoys, and different. We get. And when I say we, at this point, it's NCEI as a data center is getting some of these data, like from Canada or the Japanese Oceanographic Data Center on different times. INADEP in Argentina, different entities within NOAA. So any place that we can get these data, we gather it together into the World Ocean Database. And of course, we did talk already about the near real time from GTSPP and Argo and so on. So we bring all of that data together to get a historic up to the present time series to make these studies. So this is an example. We work with different entities in Brazil, the Brazilian Navy and the Brazilian government and institutions there, and have over the years gathered together Brazilian ocean profile data into the World Ocean Database. We have data from 1954 to the present, both CTD data, expendable bathythermographs, and moored buoys, because the Brazil's involved in the Parada array. So gathering these data together is all of these data, or most of these data, were taken pretty close to Brazil for specific monitoring of fisheries or to study physical phenomena in the Brazilian waters. But these information are extremely valuable on a global scale, especially here, especially into the tropical Pacific. Amazon outflow is very important, different things. So these contributions from Brazil, when they're put in a global database, can really enhance the global picture. But in reverse, there's a lot of data in the Atlantic that the Brazilians can then use back for their own regional needs to inform their studies and their decisions about Brazilian near coastal waters. So this is basically using a pooled data resource and something that can feed into the UN Decade of the Ocean, Decade for Science and Societal Enhancement. So as I just spoke about, institutional and national data centers are contributing to this global understanding by contributing into the World Ocean Database. Then those global data contributions contribute back to the region, at the regional and even local level for understanding as you get data from outside your own country's region, or inside your country's region for that matter, but taken by international ships. So when you go to the global ocean heat content, now we have this global picture. We can start to understand the rate of global warming, which is extremely important going into the future for mitigation, for understanding what we need to do to adapt or to hopefully try to slow that rate. Then other things like sea level change, steric sea level change, thermal expansion, haline contraction. These have global and regional implications. Ocean acidification, which was spoken about before. Freshwater inputs, which you can get from salinity. Deoxygenation. So as water gets warmer, it holds less oxygen. That has implications for the biology. And then these are ecosystem impacts. So the World Ocean Database and gathering this information together can help look at all these things on a global and then down into a regional scale. So the WD has a lot of project connections across IODE and out past IODE. So of course, World Ocean Database has been a IODE project since 2001. And at this point, we now have data mirrored from the World Ocean Database directly on the IODE server. GODAR, the Global Oceanographic Data Archaeology and Rescue, where we work with other countries, other institutes around the world to bring data that may be in paper form or in other types of magnetic tapes or something, get that into a digital form, get it into the World Ocean Database, and that's the conduit for GODAR. Global Temperature and Salinity Profile Project. So that is the near real-time data that is fed into the World Ocean Database. And not all that near real-time data is replaced later by delayed mode. So for a lot of the data we get from GTSPP, that is the record. We don't have anything else. As I spoke about before, the World Ocean Database is a CMOC in the Marine Climate Data System. Then there's the IQUAD program. I have a poster on that outside for the IQUAD community. That's International Quality Controlled Oceanographic Database. So it's one thing to get these data, heterogeneous data, into a database. It's another thing to make sure that that historic data is all usable, even up to the present. So IQUAD is gathering experts from around the world to look at those data, even on a one-by-one profile basis, and make expert quality decisions. And that feeds back and is represented in the World Ocean Database. And we also have some connections which we'd like to develop more with OBIS to hopefully include profile data with that biological data within OBIS. So there's a lot of connections globally for the World Ocean Database that can enhance into the UN Decade of the Ocean. And of course, all the data that comes in, that goes into the World Ocean Database, is also kept in the archive at NCEI. So if you don't believe the World Ocean Database and the quality control, or think there might be something wrong there, you can always go back to that original data. So I spoke about this as, I guess, kind of a wrap-up. Why use WD as a global tool for ocean profile data? Well, it's long-running, well-established data set. So we have a large oceanographic community that both for input data and that uses the data. This can avoid duplication of effort. Instead of different groups around the world gathering data for different parts, different regions, or so on, we can use, thank you, the World Ocean Database as a single repository, and then these regional and local experts can help do the quality control on a global scale, so you only have to go one place to get the best quality data. Of course, it's quarterly updates for climate studies. That should be, I would think that's good enough. There's new data put in and improved versions of the historic data. So there's a large community that inputs the data, that uses the data on both sides, and which is not shy at all about telling us about the quality of the data. And so we get that feedback, we make changes in the database, we get improved data sets, so we're always updating and have what we hope is the best quality source for the global data set for ocean profile data. And as I mentioned, connections with the other international products. And I didn't speak about this, I wish I had put more in about this, but one of the big problems in the World Ocean Database, in any aggregated database, is the credit is not always apparent. Even though the institute, the project, and so on is with each, that metadata is with each ocean profile within the database, it's not always evident. So we're working on retaining DOIs that come, digital object identifiers that come with the data. So you can get back to that original source, you can know who it is, who has worked on it, and even more, we're working on something, this is from Guy Castigliao at Scripps Institute, is working on this, cascading DOIs. So not only do you know what project, what institute, but you can know who actually made the measurement, who did the initial quality control, and all of these type of information can be set up in a network of DOIs that you can get from the one DOI that you find within the data. So that's really important for getting credit back to those who have contributed to it. Thank you.